Hey everyone, we are continuing with our volumes. This is our part 2. So this time we have two functions here. We have the square root of x again, and we have 1/3 x, and we're looking at 0 to 9. So you've done the area of a region like this before, and that was no big deal, right? What we're doing this time is we are going to take this region, and just like before, we're going to spin this guy around the x-axis. So I'm not going to try to draw this because I can't. I try to visualize it, but even that, I don't really worry too much about it because really what I care about is going to be just draw a sample rectangle in. So I'm going to draw my little rectangle. So here's my rectangle. So if I spin this guy around, I have the inside part in red making a circle. I have the outside part in blue making another circle. And then I have some thickness to it, so I can kind of go like that to try to give an illusion of thickness. I can speak. And just to give like 3 dimensions here. So here's what I have. So this is a little bit fancier than before, but there are certain things it has in common. One, that skinny dimension on that rectangle is still dx. That's thing one. Okay. I mentioned in our last video that there's a technique, and that technique is area times thickness. So that's what we're going to come back to, is area times thickness. So if we look at this region, I'm going to draw it sideways just because it's easier for me to draw sideways. It's so hard for me to draw vertically like this. So here's like this one sample disc that I'm pulling out. Like if I imagine this being like a big old like loaf of bread, this would be the weirdest bread. And then it has that hole in it. So if I look at this guy, which I just drew it sideways only because that's what my hands can do better. This is just a circle. Like if you look at the area, like if you imagine this is a slice of bread, I like the slice of bread analogy, gluten-free if you need it. So if you have this as a slice of bread, the way you find a volume of any region, you pull out your single slice of bread and you say, how much space do I have for spreading my peanut butter or sun butter, because you can't have peanuts, whatever. We're allergy friendly around here. So it's how much area do I have to spread my peanut butter, my jelly, my whatever. So I have like this region there for my peanut butter, which is really a circle, right? It's this top thing, or this outside thing. I'm going to still make it 3 dimensions just to show it is a slice still. And then there's also the hole in it. So really the area of this guy is the entire outside one minus the inside one. So you could even think of this as the whole minus the whole. But you have to look at your spelling. Whole with the W minus the whole without the W. That must equal W, right? Because you take the whole away from whole, you just get W. Ba-doom, math joke. Not really a math joke, just a bad joke. Sorry, not sorry. Okay, so to get this thing, like this whole, the entirety, the blue thing, is pi r squared h. For the sake of being able to talk about it easily, I'm going to also put a little O here for outer. So this is pi outer radius squared times h, because it's still a circle. And then minus the inside one is pi times the inner one squared times the h. The whole minus the whole. Okay, so looking at this, I have pi's in both places and I have h in both places. My h is dx. That's the thickness. So I have like my h here, which is dx. And I have this pi. I'm going to factor my pi to the front. This is just setting things up to make things tidy. So I have pi. I'm going to factor the front. I have my h, which I'm going to go ahead and replace with dx. And then I have my outer radius squared. Sorry about all the pen clicks, minus the inner radius squared. So we've set ourselves up. This is the volume of our slice. So it's our slice volume pi times the outer radius squared minus the inner radius squared times dx. Notice this is not the same as like outer radius minus inner radius in parentheses squared. That's a totally different thing. Be really careful with that. It's kind of like when people ignore foiling. So setting ourselves up. So my outer radius is this blue guy, the square root graph. For the sake of, so this, sometimes we refer to them as like, we'll just say, let this be y1 and this be y2. And so this is y1 that's getting squared, and then minus the y2 getting squared. Some people like to do it this way. If you're doing this on your calculator, doing it this way is really, really good because it tells you what to type. And we will have an example showing doing this on our calculator. But I want to set us up for doing it by hand first because you need to be able to do it both ways, and the assignment will have it both ways. Okay, so to get our whole volume, it's going to be the sum. That's an S for sum, right? Our bounds, since it's a dx, we look at what the x's are doing, and they're going 0 to 9, just like our previous example. And then pi, I could put that to the front if I want, and I probably will move it. And then y1, which is root x, getting squared, minus y2, which is 1/3 x, getting squared. And then all of this times dx. And I'm annoyed that my color coding just fell apart and I'm compelled to fix it. I know none of you know what I'm talking about with that. Okay. So before I integrate, first I'm going to clean this guy up. So I have v equals, I'll put my pi to the front. I can square root x, so I have just an x, minus 1/9 x squared. Be careful when you're squaring that 1/3 x. dx, include the bounds. So we're all set up. We can integrate. So we have pi times 1/2 x squared minus 1/9 times 1/3 x cubed. I know I can write that as 1/27 from 0 to 9. And then plugging in the 9, we get pi times 81/2 minus 1/27 times 9 cubed minus, and then all of that minus a 0, remember? So, and we can totally stop here, but if you keep going, you get 13.5 pi or 27 pi over 2. Either way, however you like it. So the key thing on this, though, again, is we say, when we look at that slice, and we say, imagine this is a piece of bread. It's the area of the slice times the thickness of the slice. And then to get the entire area, you integrate because you're summing from the start to finish. Okay, stay tuned. Next time we're going to go, instead of around the x-axis, we're going to go around the y-axis, and I apologize in advance.